All right, it's 5:03 and therefore we shall begin. Uh, Thank you both who are here on Zoom. There's no one in the room with us, and so we're just going to be addressing you guys if there's any questions. So feel free to unmute, send a message, whatever you need, if anything pops up throughout the event. All right, things we're going to do today between Carlos, Felipe, and I, we're the three tech leads who are running this event. We're going to just cover some background about what the point of APIs are and how you're going to end up using one. What is specifically a REST API, which is by far and away the most popular architecture. And then we'll explore how can I interact with one that someone else has created using Postman. And then we're going to go ahead and build our own. And at the end, we're going to circle back around and talk about some other API protocols other than REST APIs that you can use that have their own interesting features. All right, so really quick, I want to start with a little bit of background just to sort of set the stage about what we're doing here. And I'm sure that both of you guys at this point, or all three of you now, someone just joined, great. You guys probably have heard the differentiation between front end and back end. Front end is typically everything that the user can see, and back end is everything that a user cannot. And so a user interface on the front end is designed to receive data and present it to the user and let the user interact with it, but it doesn't have the ability to persist data long-term or to really manipulate it in a powerful way. And so we really want to create some sort of system, our backend, that allows us to retrieve this information whenever we want it, to manipulate it. Maybe we have a bunch of computations or filtering or mapping or things that need to happen to it. And we also want it to organize. So we don't always need all of our data for our component. So our backend can grab specifically what we want. And with this, we need to come up with some other way than letting the front end directly interface with all of our data. This is super, super scary because we may design a front end client, whether it be a website or a mobile app, but there are lots of other people that can use all the information that's available on your front end to pretend to be a client that you've created. Most of the information about requests and responses on your website are public. You can go into your dev tools and into your networking tab and find out all of those things. So it's very easy to send requests just anyone. And so we need to make sure that no one can just, throw away all of our data or access things illegally. We need to have some restrictions in place. And so what we do instead is we design some sort of API, whether it be a REST API or GraphQL or one of the other things we're going to talk about towards the end, to serve sort of as a contract between the client and our data and let the client know exactly what they are allowed to do and present whatever response they're expecting back. So an API, formal definition here, is a set of protocols and definitions, or a contract per se, that specifies what any given client, whether that be specifically someone who is authenticated, someone who's not authenticated, websites, it could be any type of person. You can specify in your API which types of clients are allowed to access certain routes. What are those clients allowed to do with the data, and who's allowed to actually make those requests? And then once they make requests for information, what should they expect to get back? If you send in any given parameters, you should basically always expect to get exactly the same thing back. And the format is really important for whoever designs the API to come up with and also to document. Documentation is super important for an API so that your client knows what they need to send in and exactly what they're going to get back. All right, with that, I'm going to pass it over to Carlos to dive into REST API specifically.
Thank you. So let's start with, before we go into what is a REST API, what is REST? So REST stands for Representational State Transfer, and it's basically a loose set of rules that have been the standard for building web APIs since the early 2000s. So this has a very long track record and is by far the most popular way to make APIs. So let's talk about what are the principles of a RESTful architecture. So the main principles is it needs to be stateless. So every request that you make should contain all of the necessary information. The next one is uniform interface, which means a couple of things. Initially, there are these things called URIs, which stands for unique resource identifiers. And it basically means that things should be identified by using URIs, and they should be represented using a specific format. In our case today, we're going to use JSON, and JSON is by far also the most popular way to send data through the internet. Another point in this uniform interface is sort of what Eli hinted at, that if you make the same request with the same data, you should always expect to receive the same response. Like there shouldn't be any crazy magic happening. Everything should be uniform. And the third principle, which is I think the most important one, is layered system. You need to build your APIs with each layer having a specific role. If we look at the example of a website where you can shop, so something like Amazon, for instance, when a user clicks the buy button, there's probably going to be two systems going on. The first one is going to authenticate that the user is a real user, that they have a credit card on the account, all of that. And then the second layer is going to actually make the purchase. So this is really important because it separates the system into multiple layers that can be very scalable and easy to maintain instead of just one singular layer. So what is a REST API? So a REST API is simply an API that follows RESTful architecture. That's it. It's that simple. So how do we define it and how do we use it? Like I mentioned before, URIs stands for unique resource identifiers. So if we look at the example of these two URLs, which are unique resource locators, we basically have on the left side in gray, we have the domain, and on the right side, which is /API/products, or in the second line, it's /API/users. Those are the URIs. Those lead to unique and specific endpoints that your API will work off of. So for instance, the top one might handle the entirety of the products database, or the bottom one might deal with the entirety of the users database. So these are really important, and this is how we make requests, where we make requests. So how do we use these? Well, we can use these by making requests with HTTP methods. There are four main ones: POST, which deals usually with creating new data in your database or wherever you're holding your data; GET, which deals with reading; PUT, which deals with updating; and DELETE, which deals with deleting. And all of this follows the style of something we call CRUD, which is CRUD operations. Yep. So how do we implement these in our APIs? Well, here I'm just going to run through some examples of just basic requests and how those responses should look like. So say I'm making a GET request to a /API/users. What's expected here is we probably are looking to get all of the users. And on the right side, we have a response that is in JSON format. By the way, JSON stands for JavaScript object notation. So each of the things inside of the brackets are a JavaScript object. And that's how we usually communicate data through REST APIs. So, okay, so a GET request to this URI would usually bring us like a response like this. The next example is, what if I only want the data for a specific user? Well, usually the standard is you do a GET, you do /API/whatever, and then after the last slash, you probably have some kind of identifier. In this case, it's an integer. Sometimes it can be a whole string. And that identifier is specifically what resource or what user in this case you want to get. So this is what an example of request and response could look like. Moving on from GET, we're going to talk about PUT. Remember, PUT is for updating. So in this case, I'm telling it, hey, I want to put like new data in this specific user. And what's different about this request is actually going to include in the body some information. That information is what you want to update. So the typical response for this is, here's the object of that user now updated. And as we can see, the name changed from an empty that we had before to hi. Moving on, we have delete. Delete is very simple. Just delete that specific user. Usually it doesn't merit a response with anything, or sometimes it's deleted true or false. Yeah. And then post is for creating new users. So we can just say post the general users URI and the data for the new user that we want. And the response would look like this. Perfect. So I'm going to pass it back to Eli now, and he's going to talk about important assign the section.
There's so much getting up and switching. All right. So here's a couple of just important design decisions that will come into play if you're creating your own API, which we'll do a little bit later. But first things first, security is super, super important for anything you're doing on the back end. Again, like you're designing something like this so that you can usually manipulate data, and there should be absolutely no way that anyone who's unauthorized can get into that data. So there's lots of different ways you can introduce secure features, whether it be some form of authentication or access restriction to specific routes, anything that you can do to make sure that the data communication is safe and also no one's able to get to something they can't is very, very important. And that's something that you need to keep in mind when you're designing what specifically you want to offer to the clients. Again, you definitely want to be able to limit access with authentication strategies. So you may decide that certain functions of your API are accessible to anyone in the world. Those things are usually probably not super important or not handling anything very dangerous, whereas other functions of your API are very important and you should have to be an authenticated user or have a certain access level. And those are all things that you need to think about as you're developing your API as well. Another thing, don't allow dangerous or unexpected inputs. This goes without saying. If you decide to create a route on your API that allows you to query for a specific thing, you probably want to make sure that the input that you're getting is actually correct. Otherwise, maybe someone could, inject their own SQL and execute it, which would be really scary. And also, just if you're not being careful with your inputs and you don't specify exactly what it is, then your clients are also not really going to have any idea what they need to send you. So it needs to be very, very specific and contractual. Your API is usually going to support common or important operations. So if you're creating a CRUD app, which stands for create, replace, I think, read, that makes more sense. Create, read, update, and delete. The standard type of application that just interacts with a bunch of data in a database, then you probably want to create functions that the client can call to do all those things. Again, don't expose any unneeded information. If you're creating a route, you don't want to just pass back information willy-nilly. If your route has a specific function, it probably shouldn't access any data outside that function in case something were to go wrong. Okay. So that's a lot of stuff just to throw at you guys. So let's sort of jump into the first major exploration of today. And this is an exploration of how we can interact with another API on the web somewhere. And what I have chosen for us to work with today is the AccuWeather API. So you guys can go ahead and go to developer.accuweather.com. And we're going to play around with this a little bit and make some requests and see what we can do. So first things first, we want to go ahead and register using your first name, last name, create a username, and put your email address. Business name, you can put student or independent. It doesn't actually check anything important. Phone number, all of that. And then I'm not a robot. And it's going to ask you to verify your email. So you'll have to, whatever email you put in here, go in there and hit the link to verify. I have already created an account, and so I'm not going to do this again, but I want to give everyone maybe like a minute and a half to get through this, and I'm going to go ahead and log in or attempt to. I don't actually remember my credentials at all here. All right, there we go. So once you get in here, you should be seeing your profile and log out, and you should be able to go into this API reference. So give everyone another minute, and then we'll pick back up. Set up if you need to. So once you're in here, we can sort of play around with any of these different categories. So this documentation is going to be your best friend for trying to figure out what you're allowed to do. Let's say maybe we want to get forecast information for a specific location. It'll give us all these different methods that we can use. So all of these are GET requests, which will tell us what protocol we need to use. And then we can find the URL that this particular request can be found at. And this is really small, so let me zoom in here. But you'll notice that there's a base URL, and then it starts to go into the specific route. So this route is /forecasts v1. Oftentimes, when APIs continue to evolve over time, instead of modifying an existing route because it's contractual and it will absolutely break all of the clients that use the previous version. Rather, what they'll do is when they create a new major version, they will set all of the routes to be v2 instead of v1. And so those will be different routes, different parameters, different outputs, stuff like that. So we'll take note that it's v1 specifically, and then /daily/1day, and then it gives us a parameter that is an identifier. So this location key, I don't have that, so we're gonna have to figure out where to get that from. And it gives us some more information about things we can pass in. We can click on this and go in and test this out a little bit. So things that we're missing here, we're missing an API key, which we can actually get in our profile here if you go into My Apps. And I've created an app here called Let Us Use Your Data, Please. And it provides an API key. We'll blur this for the video, but everyone should have their own API key here and a date that it's issued. You can go ahead and copy it. If you don't already have an app created, you can add a new one, just fill out all the information and then get your API key. And so I'll go back into my API reference once I have that. Can go back into, sorry, not doing that yet. Our forecasts and our 1 day of daily forecasts. So we have our API key, which is required, which means we have to pass that in. All these other things are optionals. We could say give us the full details in our response. One thing we're missing here is our location key. So this is a unique identifier for a specific location. We do not have this, and so we need to go back into our API reference and our locations API. And here's what we can do. We can search for a specific city and get an array of things that match, or we can search for our top cities. Let's do that. Let's search for the top cities. And we'll go ahead and update this value at the top here to be our top 50. And then let's paste in our API key again. Our language details, we'll leave that out, and we can send this request. So this is, they've created a little client on here that we can use. And it gives us all this information down here. If we scroll down, this is our response. So Bangladesh, Dhaka is our top city in the world. So let's go ahead and take this location key up here, 28143. Oop, and I've copied the wrong thing. Yeah, I'm getting to it. So we go into our API reference here in our forecasts API, get 1 day of daily forecasts. And we can paste back in our API key and then 214. I've already forgotten what it was. I'm just going to put in some random numbers here. This is surely going to be some city. And let's set this to be true so we can figure out what it is. Cool. So wherever this is, it is a pleasant Sunday. Daily forecast. Temperature. There's so much information. But I guess that's what I asked for. All right, so long story short, we can go ahead and send requests like this, or what we're going to do is we're going to use Postman to do this just so that we can create lasting requests and I don't have to like constantly go back and forth in tabs. And at any point, we can just go ahead and send that same request and test out our API. So you have a question here. Are these templates for calls or the exact calls we are allowed to use? So these are all like the exact calls you're allowed to use if you go into the API reference. So if I wanted to get the current conditions somewhere, these are all the things that I am allowed to do, nothing else. If you send a request to any other URL, it's not going to do anything. And if you send it to this specific URL, it's going to do exactly this thing that it's describing. So this is very contractual. Anything that's required, you have to pass to it. And you can't, mix and match. You can a little bit with other protocols like GraphQL, which we'll talk about briefly, but even then, it's not like you can just do whatever you want. So here's what we're gonna do. We're gonna go into Postman. So let's go to postman.com. We can sign up for this. I'm already logged in, which is gonna cause some problems. So let me do this. Let me log out here. Just go to the base. Okay, so Postman is a super useful tool if you're developing an API because it allows you to store a bunch of different requests and parameters and all kinds of stuff. And you can literally just click the send button to test out a route and figure out if you're getting the right thing back. You can set up unit tests so that it can check the input and the output for you and make sure that it's what it is expected. This is absolutely critical for if you're going to design an API, and so we're going to use this a little bit. You can either download the desktop app for this, or you can use it in the browser and just sign in. In order to use it in the browser, you will need to download the Postman agent. So if you download the desktop app, I think they should come bundled together. But if you're using in the browser, you need to at least go into the product section. And tools, I think, is probably where it is. Bless you. This is not it. So if we search for Postman agents, you can go ahead and download this for whatever OS you're using, and you'll need to download it and then run it. And your Postman agent theoretically would run when you log in for the first time. And it allows you to run a server on your local host. So running on your computer just for a development environment and connect to it. We don't need that right this second. So all you need to do is sign in, but you will need the agent or the desktop app for when we create our own API right after this. So let's do this. So let's go in here. Let's grab our API key one more time. Most APIs will require you to create an API key or some authentication scheme that allows you to, when you send a request, validate, I have registered with your API. I am authenticated. I am a real person. And if that key is missing, it will just go ahead and reject it for you. So let's, once you're in here, we can go ahead and create. There's so many banners on here. It's unreal. We can create a new workspace. Let's call this weather testing. And we'll set this to be personal. Cool. And so we have a workspace, and over on the left here, we have an empty set of collections. A collection is like a folder of a bunch of different requests. Let's create a collection here and call this current conditions requests. You can name this anything you want. And let's create a new HTTP request. And we can go ahead and let's do a couple things. So I'm going to temporarily just paste in my API key, which we'll put somewhere better in a second. But let's grab the specific URL that we're requesting to. So let's go into current conditions. And we'll get the current conditions for a specific location. And we can copy this whole resource URL, which is where we're sending our request to. Let's put this up first. Okay, so we have that. I'm going to grab my API key again. We can also name this request. It'll ask us to save it. So let's call this current conditions. And we'll save it to our current conditions collection. So we need to do a couple things here first. We need to find a way to insert our location key, which we could hard code in here. This would totally work. In fact, let's do that initially just to prove that it works. And we also need to specify query parameters here. So these query parameters on a GET request allow us to pass in information to help like narrow down our results. And this is how they've specified that they want their API key. Oftentimes, an API key needs to go into the request header, which is a bunch of meta information about your request, but they've specified that it needs to be a query parameter specifically. So we can create a query parameter by, at the end of our URL, adding a question mark and then the name of our parameter, which is API key, all lowercase, that's what they've specified, equals, and then our hard-coded API key. And so if I save this at this point, we should be able to send this and get something back because we have our API key, which is valid. We have a location, which is theoretically valid. And let's send a request. And we get back a bunch of stuff. So you'll notice a couple things here in our outputs. There's a status over here. A status is a code that gets sent back with every response that just tells you what happened. A 200 okay just means, yeah, it worked. You might get a 400 something error, which usually means there was an error on your end. You, the client, have done something wrong. Or you could get a 500 something error, which would mean that the server did something wrong. And your documentation will specify exactly what codes you can get back. Like down here, if we scroll down, these are all the error codes we could get back for errors, or we can get our 200 success. And things that we got in here, we got the temperature in Fahrenheit and in degrees Celsius. We could add an extra query parameter on here. You'll notice that the other parameters that we're allowed to specify are the details. So do we want like the full output? We can use an ampersand, details equals true. Send it again and we'll get way more information now in case we wanted all of that. Let's create one more really quick. Let's grab a location dynamically. So let's do city search. If it's going to load. Did I like disconnect or something? That'd be terrible. Let's try this again. API reference, locations API. City search. All right, here we go. So let's grab this URL here. Let's create a new request. We'll paste it in. Query parameters, we need the API key and also some text to search for. So API key, we'll grab that from our other one over here. And let's search for Orlando. Put in any city you want in here. That's location. And we'll save this to our collection. All right. So now this is saved and let's send this one. Cool. And so we get our location key 328169. That looks very close to a zip code. We could put this back into our other one and replace our location code with our updated location code. And so now we have the information about Orlando. Sounds about right. All right, really cool. One last thing I want to do before I pass it off to Felipe really quick is hard coding this stuff kind of sucks. It's very hard to manage, and it would be nice if we could specify our location key or our API key in one specific location and use it everywhere. And that way we don't have to like constantly update it on every single request, where with a big API, you're gonna have a lot of requests and it's gonna be hard to keep track of everything. So we can go over here and create an environment. An environment is just a set of variables, and we can activate one particular environment, and then our variables, the value in that specific environment is available everywhere. So we could add our API key as a variable here and give it an initial value of that long API key. Come on. There we go. And then we can grab our specific location that we're interested in, which is this location key, and go into our environment. Specify a value. All right. So now we have this, and this is our environment. We can rename it Orlando, maybe. And this environment is activated. By default, it should be. Oh, never mind. We can go ahead and activate our environment up in the corner here. And so now what we can do in our specific collections is for our get location, we can take out our API key. And then in two brackets, we can get the variable API key. And so if we send this again, it's still going to work. Our API key is still valid. In our current conditions, we can take out our API key. And we can also take out location key. We can send this one too, and this one will also work. Note, if we didn't have our API key, which the documentation said is required, and we send this, it's going to say we're not authorized, which is expected. So you can use variables in environments, which is super helpful, and we'll do a lot more of that. Okay, that's everything here. There's lots of fun stuff to get involved with, but I'm going to pass it over to Felipe, and we'll be good to get on to the next section. Oh. Okay.
Is it okay if I just, is there any like files?
You can do whatever you want.
Okay.
And lights off a little bit, so it's easier to see.
So we'll like create our own REST API. So you can name it whatever you really want. I will name it like API for sure. And let me open this folder. So just wait a bit. And let me open the terminal. Okay, so for you to build this API, you will need to have Node.js installed, which is what we use to run JavaScript code. This will be a Express API. So the first thing that we should do is initialize it, which is np init. It will ask you a bunch of things. You can just ignore it. Yes, yes. And then you should see a package.json file. And that's how you know you got it right. So, but now we're gonna install some dependencies that we need. We will, as I said, this is gonna be a Express API. And we will use body parser to this is like the main thing to like read data that's being sent online. And we use Nodemon to run it. Nodemon is it's not that important. Express and body parser are the really most important parts, but you would need Nodemon to run it. But yeah, so that will take a while. So if you guys have any questions, make sure to ask. I'll be checking chat from time to time. Is there a link we're supposed to go to? No. This is to install Node.js. I'm pretty sure if you just type like Node.js in Google, it will be like the first thing. It's like a really big thing. Oh, make sure those are the right packages. Okay, so if you want to make sure, so if you use Yarn, you will probably. I'm not quite familiar with Yarn, but I'm sure the packages name are still the same. So it would be Express. I will type it in chat. The names. Everything I don't think it will matter if it's. So these are all the names for all the packages that we are using. So let me know if that helps. Okay, we're gonna start. So the first thing that we gotta do is call our dependencies. They are like Express node parser, and it's called by calling their names. We also create a usually, I mean, if you're gonna use Express, you need to create an application, which is what we're doing right here, using the Express function. Then we're gonna create one for the body parser. So these are just recalling the dependencies that we downloaded just now. So if you have any questions, please let me know. Okay. So once we have that, we can, oh yeah, also we need to make sure our application is using body parser. This is like the main thing that we will use it for. Is that body parser JSON? I'm correct. Give me a second to check that. Yeah. Okay. So this makes sure that we can read data in JSON and also send data in JSON, I think. We will also set a constant for our port that we are using. So we're gonna use port 3000, which is like a default one. All right, so now is where we actually start coding. But before we start, we should create some data that we're gonna be messing with. Yeah, it's okay. Is there some? Can you not see the screen? Okay.
Oh, it's only screen sharing Chrome, I think.
Okay. Thank you for calling that out. Okay, can you see it now?
Sorry.
Yeah, let me know if you guys need some time. If you have any questions or anything. So this is like the first 3 lines. This is just calling the dependencies. Let me know if I should wait. I will give you guys like a few minutes just to make sure. Okay, maybe not a few minutes. So will be our data. I'm not sure what we're gonna write here yet, but is what we probably will just write like a simple array of objects, and all these objects should like represent people. I would give them IDs to label them. And if you're not familiar with like an object in JavaScript, this is how you do it. So we will have an ID, a name, and an age. Name Bob. And age, which will be 20. And we'll add one more just so we can test things out. Okay. So this will be our data, what we'll be messing with. So our first, usually the first request that people make is the GET request. This one's gonna be just simple. They will just do a simple GET request to our API like URL, which will be just localhost for now. I mean, yeah, for the entire time, because it's just this is gonna be like an API that we will be running locally. So we will get a response and a request. So every HTTP request that is made has a like what is the request and a response to it. And for example, the response to it includes things like as you've seen, like status and all the data that's sent with. And the request is usually like what we're asking for. And like what type of request is it and things of the sort. So this will be a very simple one. We'll just ask for some data and we'll just give them back. This is like REST is response right now. So REQ is the request that they made and the REST is the response. So this is what we're sending back to them. So there's two ways to send back to them. You can use JSON and then include in parentheses like what you're sending back to them, or you can just use the send function. I use JSON for now, but you can do both ways. So we should probably start like testing the API, make sure things work. And to do that, we'll have to write some one script to make things easier for us to run it. We will be using Nodemon to run it. So every time a change is made, we will be able to, the API will reboot itself. So that's what Nodemon does. It reboots like our code itself without we having to do anything every time there's a change to the files. So this is how you write the script to run it. And now we should be able to use the terminal to run this. Nice. Okay. So let's go back to the web browser. This kind of on my way. Okay, it's fine. So let's create a new request, localhost. And the port that we decided to be on is 3000. So we also decided a route for it, but the route for it is just a bracket. It's just like the default. It's like the default API key, pretty much. I mean, the route. So this is like the default thing we're sending to them as soon as they call our API. And let's see if we get anything from this. Okay. Localhost for 2000. Let me try. Nice. Okay, localhost 3000. Okay, so things broke. Let me see if we got anything in the console. Nope. Okay, give me a second. Let me figure out what happened. It should be running. Oh, I see. Yeah, you at the very bottom. Okay, yeah. I forgot to run the app. I mean, we have to choose a port to listen to, and we have to choose the port. That's why we at the beginning of the we labeled the port 3000. So we haven't decided what port we are using yet, but this is how you do it. So the first part will be the port. And then the second one is like a message that you want to give to them, like for example, like run a function. Oh, yeah, this is like a function that you can run. So usually people use this function to pick something for it to say, for example, like to make sure that things are working, like a console log. And everything is running fine. And as you can see, oh well, I guess everything works can be misleading. Okay. So let's try that one more time. Oh, nice. So if we try it right here. Nice. So we get the data that we were talking about, the ID, the name, and the age of the two people we have. So this is a GET request. So we are getting the data from the API. Now, the GET request is like a really simple one. Now let's do, let's add data to it, like a post request. So to do that, we use post, I believe. Yeah. So we're also going to use the same, like, this is just going to be a different request, but it will be a post request instead of a GET, but we will use the same URL. But we will check if they're asking for data or if they're trying to send data to us. So every request has response and the request itself. That's over there. So this one will be a little bit bigger, but not much. So we'll push, which means that we are like adding to the end. It's a JavaScript function that adds like a whatever object whatever we throw here to the end of the array. And to access the data that we're trying to send, we'll use the request, and we use the body of the request. So the body of the request is like what we are trying to send to them. And once we do that, we need to give them a response. And our response can be the same thing that we responded to them before. It would just be the updated data that we got after the change that they made to it. So here it goes. Let me label this. Okay, so now we can go and test it out in Postman. Let's create a new one. Localhost 3000. And instead of being a GET request, it's going to be a post request. So now we need to give it like a body to it, and we need to send them like what type of data we are sending. And when we're doing that, we always want to use JSON because I mean, for our API, because that's what we're using. We're using bodyparser.json. So that's the kind of data that we're expecting. So if we send them anything else, they probably won't be able to read it. So that's why we want to make sure we're sending JSON. So we will send a new person. And an age. Okay, so now let's try sending this to our API. Okay, nice. So we can see our data been modified. And of course, because we don't have a backend, if this was to relaunch itself, we would lose all this data. So as soon as we make a change to the code, we will lose everything we send to them. And also there's a lot of problems with this API. For example, this is not very secure. This is just a demonstration. So for example, we can send them whatever we want. So there's no limit, like where there's no minimum of things we can send. For example, we don't have to always have a name or not always have an ID or not always have an age, so we can send them whenever. So it's not safe. It's just for demonstration. And you will also see how to add some variables to the parameters for the request that we're adding soon. But now let's do the delete. So we can delete one of the users. Actually, I'm gonna create one more person for our thing, because now that we start deleting things, two might be too little. Oh, what happened? Yeah. And we'll be using app.delete. And this time, instead of just being the root, we'll need like an ID, like what are we deleting? Or we could also have just the root and delete like the whole thing. But it would make more sense for us to just delete like one of the IDs of someone that's within our data set. So let's do that. So right now, this ID right here, because I put like the two dots in front, will be kind of like a variable. We'll be able to take a look at what is their exactly value that they send, and it will traverse through our data and figure out if we have someone with that ID, and if we do, we will delete them. So every request has the request and the response. So we'll have an ID variable, which is what we require them to do to get to do the request. They will need to have like an ID of a user that's already exists in the API, and that can be found in the request parameters and ID. And once you have that, we need to figure out like the index, like where's that person in our array. So to do that, we'll create an index variable and we'll run a function called find index. And this function runs, it traverses through the array until it's true. So it will get every element or item. And if it's true, it will just give the ID of the item. So an item would be every element in this array. So for example, the first item would be Bob, who has an ID of 1 and an age of 20. The second item would be Chris, and the third item would be Chris again, because I just copied him twice. So to run that, and once this condition is true, it will break. Not break, but return the index of that. Okay. So now once we have all that, we can just delete by using, yes, this one. Splice. I guess that's how you call it. And just the index off of the that we have right now. I'm not quite sure what that one is for, but yeah. And once we do all that, we will just respond the JSON again. So we will just send the JSON data that is the updated version of the after the request that they made. So we can test that right now. It should be running. And let's select ID. I mean, of course, as well as I said before, there's a lot of issues with this API. For example, I can choose an ID that's not within our range, but it's these are like some simple things that you got to be thinking about. Of course, if you're actually trying to make an API, you want to make sure you check it if there's a way to deal with it, because right now, let me go back to it. If we don't have the ID in it, this find index function will return for us -1. And then once we try to access this -1, it probably won't be happy. It probably won't like it, and it probably break on us. So we got to make sure that we have like some way of dealing with that if you were actually making a real API. But right now, we don't really have to worry too much about it. Let's just see if our delete works. So we deleted the ID1, which was Bob, and we can also delete ID2. And then we can also delete ID3. Okay, and then everyone is gone. So our delete request works perfectly. So now let's go back. So a CRUD has read, which is our get. Oh, I guess it has create as well, but I'm not sure. Oh yeah, we can do create. So the get is our read, the post is our create, and the delete is delete at the very last. We don't have an update right now, and let's code the update right now. So we have all the CRUD operations done. So update is usually done by put or patch. The difference between put and patch is that patch modify existing data, like just a part of it. For example, if I was to patch Bob, I could change his age or add his profession. But if I was to do a put is more of a, like I'm changing the whole element. For example, I am gonna completely change Bob. It's not gonna be Bob anymore, and he's not gonna have the same age. Gonna have a different ID, and everything about Bob will be like completely changed. So that's the difference between put and patch. They're kind of similar. They're both updating data, but put is more extreme, and patch is like just part of the data. So we'll again target it like ID, which ID we're gonna change. And we'll be using some very similar stuff that we saw in the delete. Okay. So again, we'll get the ID. We'll see if we can find the ID in our data. And again, we'll be using something that's very similar to what we did before. We're doing a different operation. Instead of deleting, we'll be modifying them. So now that we have this data ID, so we have the index of where we're gonna want to change, And what we adding to it is the request body. So whatever they send to us, we will replace like the first person or oh yeah, we're doing by ID. So like the person with this ID or the person with that ID. And then we'll send them a response in JSON. Right, nice. So let's test out our update function. So be we will require the ID, and this time we will require a body, and our body size in JSON. Change it. So change Bob's name, which is the first person, to Emily. So let's see if that works. Okay, so you guys can see here the first person is changed. We can also change their age one more time just to make sure we are actually changing it. So you can see the age change to 22 to 21. I mean, from 21 to 22. We can also do 35. And that will be all the CRUD operations for a very simple API. So get would be the C. No, get would be, okay, let me move them a little bit. So post is create. Get is the read. Put is the update, which is you. And delete is the D. So this is a CRUD, a simple, very simple CRUD API. What if we do not give age? So if we don't give them an age, it will be completely fine because we don't have any security parameters. If you are although coding an actual API, you should be very careful about what you take in from the requests, and you got to make sure that they are formatted properly. So this is just a example. That's not this. You won't see this in the real world because people will probably mess and break the API. But I can also show an example of me probably breaking the API. You see that our put right here is asking for an ID, and then we're gonna try to find this IDs in this array. I mean, in our data, and if we don't find the ID one, for example, if the ID one doesn't exist, it will return to us -1. This find index function will return -1 if it cannot find anything. So then we will go to data, and then we're gonna try to access the -1 index, which of course will break our code. So we can try that just so I can show you. It's not a safe API. It's just a very simple one. Did it break? Okay, maybe it doesn't break, but it's not safe. You still should be doing checks. I'm not quite sure why it doesn't break. Not sure. Maybe it does wrap around, but then it would have changed the last one, right? Because then it would have wrapped around and then changed the Chris, which is the last element in the array. So it's interesting that it doesn't break. Could you put a max number and break it that way? You mean so because I believe, oh yeah, because in JavaScript they only the numbers only go up so far. Yeah, if you send too big of a index, it will probably break. I'm not gonna be trying to break it, but this is not safe. That's what the main point I'm trying to make. You definitely want to make sure you check whatever is being sent for when you're doing a post and a put, which is the updating, and posting is like sending, creating a new person. You want to make sure they have all the credentials, a name, an age, and an ID. And you want to make sure that if they have anything less or more than that, you deny the request. And also, if you're deleting, also you need to make sure that you actually have something to delete. And yeah, I think that will be all for the CRUD API. This is a very simple API, and I believe I will be sending in the GitHub repo if you guys want to check it out, if you guys couldn't follow along. So it'll be all okay. Yeah.
Hey. Hey everyone, this is Carlos. So we are like almost out of time. We need to go in like 5 minutes. So I'm gonna really quickly run through some slides that we had for different types of APIs. I'm gonna run through it like super quick. So I'm sorry if I can't give you like all the context, but I will post these also in the event resources. So basically some other types of APIs, GraphQL APIs are becoming really popular. They were released by Facebook or Meta in 2015. The QL stands for query language. It's open source, cross-platform, et cetera, all the good stuff. So basically, here's like a visual representation of how REST API works. You have like 3 different endpoints, right? And they all bring you like different things. But this like confronts us with like 2 issues. Say that we want some kind of combination of this data. We want something from the astronaut, something from the rocket, something from the moon endpoint, but we don't want all of the data. This presents us with 2 problems. One is called, okay, sorry. Hopefully this isn't covering it. One of them is called underfetching, which means at every endpoint that we call, we're basically fetching less data than what we really want. When we're contacting the astronaut endpoint, we really want a combination of all 3, but we are only getting like one of them. The next problem that we face is overfetching, which is, say we only want the name of the astronaut and their date of birth or something. In a REST API, in a typical REST API, you're going to receive the entire package. You're going to receive all the data, just like we did with the weather. We're going to receive all the data instead of just the one that we want. GraphQL approaches this in a different way. We have a singular endpoint that will, you will ask it specifically what you want, and it'll give you exactly what you asked it for. It does that by using query language that they created. On the left side, we have an example of what a query might look like. It's, you basically ask it exactly for what you want. I want the rocket with the name of the rocket, the captain, the name of the captain, and the call sign of the captain. And what's beautiful about this is if you're like a front-end developer, you would love this, because you literally just ask it exactly for what you want, and you can see it mirrors the shape in return. It has the exact same shape that you asked it for, with no extra data and without having to deal with calling multiple APIs and then all that stuff. Okay, so that's GraphQL really quickly, and then gRPC is the last one that we have. gRPC is a framework. It's open source, cross-platform. It's called the High Performance Framework because it's very fast, and it was released by Google in 2016. Some quick notes about the differences. As we covered today, a REST API is just an API that follows REST. Meanwhile, gRPC is an actual framework. It's an RPC framework. So the comparison would really be better if I say something like Express. Express is a REST API framework. So gRPC is basically a framework. One of the cool things about it is that it allows streaming. Meanwhile, a REST API is very constrained to only requests and responses. gRPC can do that too, but then it can also allow for streaming data. One quick example is if you have the Lyft app, the ride-sharing app, and you request a ride, and you can see the live data from the driver's location, like you can see exactly where they are, how close they are. Lyft actually uses gRPC for this. It allows for the constant streaming of data without a specific request and response. It's also very fast again. And the secret recipe for this is that they use protocol buffers instead of JSON. So one quick thing, okay, so we'll go over some JSON pros really quickly. One awesome thing about JSON, it's human readable. So say I have this example of a program sending another program a JSON. We can all see, we can all see how readable this is. It's got two fields, a timestamp, a URL, it's an integer, the other one's a string, super readable. That's one of the great things about JSON. It's also self-contained, following REST principles. We want everything within that JSON to have everything that the Python program would need, for instance. And then easily extensible means I can add, like the Java program can add like 10 more fields to this JSON, and the Python program could not care. Like it, as long as it's using exactly part like what it needs, it's very easily extensible. You can expand it or decrease it as needed. Some cons about JSON. JSON can get pretty massive. If we look at the example, the same JSON from before in its most compact form, removing any new lines or white spaces, this is literally what's sent from one, like from one endpoint to the other. It's actually, it just puts quotation marks around the first bracket and the last bracket. It's like literally a string. This is exactly what's sent. And if we look at the size of this is, it turns out it's a 51 byte message. If we look at the actual content though, the string is 19 bytes. The integer is only 4 bytes if we're using 64-bit integers. This comes out to 23 bytes. So less than half of this message is actual content. So that's one of the downsides of JSON. And as you are a company that, you know, has like hundreds of thousands of these calls every day, or you were just a college student and your app like skyrockets with usage, it can get really expensive really fast because of how massive it can get. And then the other thing is it has unclear types. So there's nowhere defined apart from outside documentation. There's nowhere programmatically defined that timestamp has to be an integer, for instance. Someone could just switch it to a string and break everything. So that's not great. So how does protocol buffers or protobuf address this? You declare a schema beforehand using proto language or protobuf language. It kind of looks like this. It just message is just the keyword that defines an object. As you can see here, we're already addressing one of the thingies, which is type safety. So we have the two fields and we have their types. We know what type they're going to be. And then the other cool thing is that it goes straight into binary. Here's where we do the trade-off where it goes straight into binary. So it's really easy for the machine to read, but it's not human readable to us. The way that it uses this proto file is basically the server and the client, or in this case, these two programs, they have a copy of the schema file. So you don't need to send the field names. You don't need to send anything other than just the actual content, only the content. This makes it, and there were, I think, some open source studies that revealed that gRPC in a lot of occasions can be 7 to 10 times faster than a REST API, which is why it's the API of choice for big companies transferring a lot of data really quickly, especially internally. Awesome. Well, thank you guys for coming, and please leave any feedback and attendance and everything, and any questions.
Oh,